Okay, let's get started. So first, let's do a quick overview of the Nexus meters. Here we have the power quality meters is what we'll start out with. So the Nexus meters are precision revenue meters for grid metering with 0.026% accuracy. These are primarily, we're talking the Nexus 12, 52, 62, 72, Nexus 1500, 1450, and 1500, if I didn't say that, 1500 plus. The meters are certified IEC 61000 4-30 for Class A, power quality, analyzer captures, and transients at 50 megahertz. And note that these are basically time intervals for each measurement are 10 cycles of 50 hertz and 12 cycles of 60 hertz type function. That's the IEC 61000 4-30. Phasor measurement is available in the Nexus 1500 plus meters. There's resilient cybersecurity tools, or I should say features in the Nexus meters. And this you'll see in the 1450 and the 1500 and multi-port IO communications and remote relay functions, displays. All right. So basically, the Communicator software is what's used. If you're not familiar with this product, it's our primary programming software tool. You can download the software from the website. It's a free download. If you want to download the professional or have access to the professional mode version, which I currently have, that's a license that you'd have to purchase. So what I'll do is I'll start my connection to our meters. So you have the software allows you to, again, connect to all our different metering products. And in this, the meters that we'll be taking a look at today, I will be setting up or looking at the Nexus 1450, 1500, and 1272 meters. And again, the subject for today was programming. So I'll just jump right in. So we can start with the 1272, which is an earlier version of, it's been around for almost 20 years, I believe, or more. This meter is, when you first connect, you see the status screen. We're just going to jump to, go to the profile and take a look at the programming. So here you click on profile, and it's retrieving the programming parameters. So the first thing that you'll see is a heading which says Nexus 1272 in the general settings screen. And this is where you enter in your CTPT information, your meter hookup, whether it's a Y, delta, 2 PTs and 3 CTs, 3 CTs, no PTs, 2 PTs, 2 CTs, and 2.5 element Y. The most popular installations that we see are Y and 2 CT, 2 PT delta type connections, but that's again mostly Y and delta type connections. 2.5 element type installations are rare. The operational frequency range is 20 to 65 hertz, and it does support, higher frequencies like airplanes and things like that operating in a 400 hertz range, 350 to 500 hertz range. Okay, so it's very important to enter in the right CT, PT, and CT ratios. In this case, you have a 600 to 5, and you have 80,500 to 115. This means that the meter, and as we take a look at it, this is typically taken from the one-line drawings or the meter CT information. that's available, and PT information that's available at the site. So the next is we talk about the limits. So the limits on the 1272, this is basically what you have. It's since we have the CT ratio at 600 to 5, it's basically automatically inserting the 600 to 5. Note that you don't necessarily have to put the 600 if you know what your current is that you want to check the limits or monitor or trigger limit function. You could change this value. The line to neutral or VAN, B to N, VC to N voltages is what you see here, which is line to neutral voltages. And the phase to phase voltages are calculated below that. And the total power, I should say power per phase is, VI, V times I, pretty much for this calculation, and the total power is 3 times that value in the frequency. So this is very limited in the 1272, but basically you can enter in whatever values that you want into the meter if you think that more accurately represents your load. So this would be something like a change that you could put in here. But then also this affects what your limits will be when you set up your limit waveforms as we go forward in the presentation. So we'll just cancel here. We go down here. The time zones are, let's go to time settings. So this is 1272 where you have a zone descriptor that's relative to UTC. And we're in New York, so it's -5. 5 hours used to be Greenwich Mean Time, 5 hours away from using that as a reference. And this meter, daylight savings disabled, but you have the other features. You could turn on auto DST, or you could create your own user-defined time for daylight savings. And the auto DST function, you have the options for align sync, enable, and disable, and frequency 50, 60 hertz. And that's basically the time settings for this meter. Note that if the meter is set for 60 hertz and you lose the line, and it's set for line sync, and you lose power, or I should say utility, there's a power outage to the meter, and you don't have, the meter goes offline, basically it will run on the internal crystal in the meter, internal clock. And that's that fallback in the event that you lose power. The meter labeling is basically the name that you'll give the meter, any relevant name that you have this piece of equipment installed on. And then this is just information. You could have a memo field. You could type in certain things if you want to give more description of what that site represents. Communications, this 1272 meter. We have 2 COM ports, port 1 and 2, port 1 and 4, and you can set the meter to communicate over either port. They're all both 485, and the port 1, I believe, is shared with the optical port. So if you use this is a whether it's a switchboard or it's a socket meter, the eye or the optical port on the front of the meter would use port 1, and this is the baud rate that you can select. You'd have to make sure when you connect to the meter with the software and your probe that they're in sync with the same baud rate, and of course the address. Port 4 is the additional port you have in this 1272 meter, and this port is generally used for other things, such as whether you want to add modules or other forms of communications, or other devices that you're connected to. And here we have one network IP address in this meter. And so again, it's limited not like when you look at the 1450, as we'll talk about a little bit later, and the 12 and the 1500 plus. I believe, well, we'll talk about that in a little bit. So these are the advanced settings. Typically you want to, depends what your criteria is, you want to maybe disable this enable sleep mode, and basically the meter goes into sleep mode to conserve power. But sometimes if you're trying to communicate with the meter and it's in sleep mode, it may not respond quick enough, and so you will have some issues communication. So it's probably a good idea to disable that. Some of the others are generic. If you want GE data port server, this must be enabled if the firmware is supported. This meter does alarm for email alerts, and so you would turn that on if you were setting that up. It does FTP client, also does act as an FTP client as well. Has a built-in web server, so you can bring this up on a web using a, I should say, bring it up using a browser, web browser, and you could look at real-time information in the meter. So that's basically some of the other things in this section on the services. You can set the meter for DNP and programming. This meter is set up for DNP over the LAN or WAN, and these are the properties of DNP connection. 20,000, if you're listening, typically the use that value is the standard DNP port number, TCP port number. And again, this is just for people who are using DNP port polling, and this would be your RTU folks, SCADA folks. This is a primary concern to them, and we'll go down a little bit further and discuss DNP. This is, we talked about alarm, email notification, and if you had the email server information, you would put that in there. If it's a server or IP address, you would put that information. It goes over port 25 as the standard TCP port number. Periodically, or some companies may restrict access to port 25. So if you were to use this function, you would have to probably find a port that your IT would allow you to use. And so the alarm monitor email address to, that's basically who's you're sending this to, and reply, and of course your subject matter. There's a general template information that's stored in this alarm that you will get from this process, and that would be sent to you. So if your email server required a username, a password, you provide that as well. Again, you'd have to work with your IT, cybersecurity people. If it's within your premise, if it's out in the substation, it may also be very tight. They may not allow that type of access. So that's something you'd have to look a little further and to discuss. This meter does enable DHCP. If you want, it will assign an address if it's on a DHCP server. And this is some of the firmware update information if you wanted to update the firmware. And I think that's it. If you could configure it like a PC, we're giving it a computer name with a DNS server, and basically that's all you would need to use this for. So this completes this section. In this meter here, we have an internal modem, and it also has an Ethernet. So that's an INP, probably 200 network card in the meter, which has a combo. It's a combo unit that has a combination network card and a modem. I don't know, many people still use this, but in a lot of cases, people use a modem as a backup in case they lose the network cable. So you may have a standby phone line available, and this is how you would you connect this. The modem gateway is available for transferring. If, let's say, you're connected to another meter and through your 45 connection to one of your ports on your 45, You could use the default or modem gateway with your dial-up connection. And again, we're talking dial-up in this case, to hand off the communications or continue with the session by addressing the other meter in that 485 loop. So we talked about, so we talked about all the settings in the communications. The DNP setting, let's cancel that. The DNP setting, we talked about our SCADA folks who are interested in looking at polling. The RTUs will be polling the meter over Ethernet, or it could be over 45. This is where you set up your object 30 analog input information. You can select which items or which points that you want to capture in your DNP polling. Let's say object 20 is your energy values that you would select. And these are typical template type labeling or points that people choose. No class means class 0, which is basically bring everything if you're polling with DNP. And it just brings back all the information. This subject is quite in depth, really covers a lot for DNP. It's a separate area where I will just, as I said, go through just briefly, but not too much in depth. So here is where you could do your object 1, and there's a definition of what the object 1, 20, 10, 30, and so on to really explain what those are. And again, if you're familiar, your SCADA folks, you would be very interested in setting this up. And so the meter, of course, supports it. The meter has the ability to do custom Modbus mapping. And of course, the meter is a Modbus meter by default. So all the information is provided in a Modbus mapping table, which is several hundred pages of information. You can download that information from our website, which will give you all the information for what addressing, for what points, and so on that you'll need. The revenue energy meter section, I should say, the energy scaling has to do with the display. When you look at the front of the meter, what values you want displayed, and this is where you have all your options for display information. So this meter is set up for megawatt hours. It can be set up for kWh or watt hours. And this is the number of digits, total number of digits you have in decimal place. So this is for, again, the register display. So looking at the front of the meter, what you want to see on the display. Here are the same VA, hour, var quantities. The meter is in test mode, energy values, how you want to set that up. And then if you want to just do this one time, one shot, set them all up, just go into your global setting and it'll just apply all your settings based on what you enter here without manually typing each one in. So that's what your energy scale settings are. Demand intervals. This is your, the meter stores its data in several ways. You could store it in, well, it's in block averaging form, rolling, thermal averaging. The meter is continually averaging the data over certain periods of time. So you can assign the period that you want it, or window that you want to store this information in. So this is a 5-minute period. By selecting this here, this reset here to perform time of use reset, time of use read on maximum demand. This is key to the time of use functionality in the meter. So that has to be turned on if you want, for instance, you want the meter to do a billing period reset at the end of the month, the middle of the month, whatever date you choose. This, by checking this box, this will allow you to see that information in the meter. And using the software communicator, you could see that during your real-time polling. I should say there's an action for drop down from the real-time to TOU to view that information. So again, this is very important for people who are doing billing to look at the reset information at the end of a period. So internal KYZ, so the meter has basically a KYZ pulse generator internally with the meter. It's pulse weighted to whatever value that you have in here. This one is 0.00, 0.011940, and 200 millisecond is a pulse width. It's enabled for Form C type connection. So, so if you're outputting this pulse externally, this is what you would need these parameters. So in this particular case, if I were looking at, this is 600 to 5, and I have 80,000, I'll just get my calculator, 600 to 5 times 80,500 divided by 115. I get a power ratio of 84,000. So I would use this value in the internal KYZ. I would multiply this. This is all secondary watt hours per pulse. And if I multiply the power ratio times 0.011940, I get a value of 999.93. So that's 999.93 watt hours per pulse. If we make that, we could round that off. So that would be equivalent to 1 kWh per pulse. So this is what the customer, whoever is getting this external for Form C contact, would be getting 1 kWh per pulse. So that's a value you would provide to them. And the same method is applied to all these. The pulse width is basically, it's basically calculated value that determines how many pulses you're going to get in the interval. And there's a formula for calculating that, which is 3,600 seconds in an hour times the watt hours per pulse value divided by the secondary watts. And that basically gives you an idea if it's 200, 250, 300 milliseconds. So that's a formula that we provide in our manual to help determine what the pulse width is going to be. So I have the number written right in front of me because periodically I have to use that to calculate pulse width. I should have the formula in front of me. Anyhow, so as we go down, there are 4 KYZ outputs in this meter, and these are the watt hours constants. They're all enabled. Form C. So Form C is the contacts is showing each contact K to Y, K to Z represents 1 pulse. A Form A type contact is every contact closure, it's a count. So Form A would be it's like a single pole constantly on, off. So it would count each one separately, as opposed to KYZ would be K to Y, K to Z counts at 1. So those are the different, and it basically depends on the type of equipment that you have that's connected to this meter that requires whether it's a Form A or Form C type connection. So this test LED is a pulse output of the meter. So if you looked at the meter and it's powered, it's got energy, it's got load on it, it would be pulsing at a certain rate. In this, it's 1.8 kWh per pulse. If you're a utility and you are testing the meter, this is an important function right here. If you're using the pulses from the front of the meter, or infrared pulses that the meter is putting out, you can also test the meter KYZ with these as well. It's just that you'd have to have a special wiring hookup to do that, and it's just a little bit more work to get that done. But the test LED function, you could just put your optical pickup over the LED and you could test the meter for accuracy using that. Note that every time that you test the meter, for if you're going watt hours delivered or watt hours received, you have to program the meter each time for each one of these. You have to change that setting in the 1272 for that, for that quantity that you're trying to test. So the next is the display configuration. So the display on this meter has a custom display. I'm hoping that I could bring it back. But basically you can set up the meter to display pretty much anything that you want. So it's reading all the blocks in the display area, all the registers to bring that back. So once that's up, we'll go up and address those. I have to take a breather. All right, so the display configuration pops up. This is, you have 3 modes that you can view. These are your primary mode, is your normal mode, your alternate mode, and then you have a view mode here, we call it test. So if you had a magnet on like a 1272 on the outside of the socket, outside of the glass, you could swipe it and it will switch to the different modes that you can view. So these are the screen assignments. That's really a big part of what we wanted to get to. This is what you'll see available for your choosing. For this meter, view mode 1 is it's only showing display, cumulative energy, and phasors, but you can choose any one of these functions to, let me see, how do you just add to view mode and add to, so you would just enter this information in, whatever you want to see on the screen, and click update. When you're done, update display, and so on. And obviously the view modes for 2 and 3 are established already. So those are some of the things in screen assignments that you can do with the 1272 meter. Same with the 1262 meter. You have your miscellaneous tab where you can adjust the brightness, the backlighting, and optical port information. And I think that's pretty much it. The test mode position is for people who are, again, testing, like a utility, be testing the meter. They require a certain amount of time to test the meter before it kicks out of test mode. So in this meter, maxes out at 60 minutes. In some cases, not enough time, depending on how many points the person's testing the meter. So, but this is a maximum time that you have. Some people could do it in 30 minutes, maybe, depends on a couple points. If you're testing a lot of different points over several hours, this would kick out of test mode. You'd have to keep putting it back in. So this is again the 1272. On the in the 1500 plus, you have a wide range of, I'm not sure if you have maybe 2 hours or so, or more of, I should say 2 hours. You have many hours. I'll get into that once we switch over to the 1500 plus. Okay, so the next is the transformer. Here we go, display, CTPT. So the CTPT ratio is basically an area where we adjust if we were to set this up, you enable it here, and you have to go into the main monitor, I'd say outside. When you first communicate with the meter or the communicator, there's a drop down, and you would, once you enable this, then you would enter those values in for CTPT compensation. And that's basically, these are losses or inherent losses in the instrument transformers that you want to compensate. You put those values in. Transformer line and loss compensation is an area where it's very popular. You want to enable that if you want, if you have let's say a transformer, we're talking transformer line losses. That information is calculated using our Tlc calculator, but you need to have the transformer report information in order to make the entries into the calculator. You do need to know if it's additive or subtractive, if depending on, let's say if if there's a customer that you need to account for losses, so you would need to add the for those losses, then you would use add watts and bars. And if it's vice versa, you need to subtract, you would subtract. And of course, this does both watts delivered and watts received. That's what the plus watts and minus watts means. And if you want just watts only receive or watts only delivered, you would choose from that drop down. And so the TLC calculator is something that is required to, a requirement for anyone who's doing transformer loss compensation to fill out. You could do it separately in your own calculations for a lot of different meter types. The EIG provides this worksheet so that, let's say if we could get transformer losses here, so that it's a lot simple to just take the information directly from the transformer report and enter it in here. And so you'll get your iron and copper loss calculations or losses, and it will just produce that value, and then you would enter it in. I'm not sure if it does it automatically update. I think you have to manually enter those in after the sheet generates the values based on what you provided. And the same for line loss. If you're doing line loss calculations, all the parameters, the length of the line, the impedances, and so on, all the calculations are just entered into the sheet. All the values are entered in the sheet. And this does the math for you and generate that the line loss compensation value for you. So that completes the transformer line loss compensation section. And then this here is co-load pickup is something that we offer in the meters, that if there's an extended outage, it may allow you to, the software, the meter does defer whatever intervals, minutes, I should say minutes that you want deferred before actually the meter starts to calculate a demand. It's usually something that you'll find utilities are utilized. They may not use this in the meter, but if they use a reporting function from a software, they can scan for that and defer the outage, the demand, I should say, after an outage. A good example is a power outage lasted 2 hours, and some utilities may defer 15 minutes, the first 15 minutes. So you have 15 minutes before you can start cranking up restoring your load or generate your active load. So if the 15 minutes is not enough, you might end up seeing your demand spike for that period in your bill. So it's something that you have to pay attention to. So the meter has the ability to do that. I'll skip down to cumulative demand. So this meter has block or rolling. Those are the two methods for demand, retrieving demand information, or I should say recording demand information. So block is 15-minute, like I think we have here, 15-minute block. It's just an average demand for 15-minute period. Meanwhile, a rolling is beneficial to investor-owned utilities who want to maximize the amount of money or revenue that they can gain. And it also prevents people from trying to do split peaks and things like that. So it basically, let's say if you have the meter set up for 3 5-minute rolling or a 15-minute period, each one of those 5-minute rolling period would, if let's say whatever value it is, the highest value in that 15-minute period, 3 5-minute period, would be submitted as the highest value or the peak. So that's a method used by most investor-owned utilities. Energy impulses and accumulations. This is what you want the meter to record in. This has to be in sync with, in the 1272, with the interval size. So in this case, if this is set for 5, the meter trending as we go down further is going to be set up for 5-minute interval pulsing. So here we are with the power quality and high speed limits. So in this area, the device profile, we talked about the 1262 and the 1272. 1272 has a power quality feature. And here we have this meter set up to trigger high-speed updated voltage, VAN, BCN, BN, and CN, so on. These are parameters that you choose. You could, again, it could be watts, it could be VARs, it could be amps, whichever that you choose, and you want to trigger an event. This is set for 120% of full scale. And again, this keys off from what we set the meter at, especially looking at voltages. This was, I think 14 or 80,500 to 115. So it's going to look at that as a PT value and the PT to determine what the voltages are. So here are your settings, the set points for 120% and 80% for your low or your low set point. Again, these are all parameters that you can choose. There is no particular recommendation to choose whatever, to use certain values. That's all totally up to the user. And so you have 10 of these that you can, let's see, I think it's actually 32 assignments that you can set up. And these are all able to go out, trigger, send alarms. And that's part of when we talked about the email alarms, that's part of the setting this up and having those alarms sent out will be sent based on this information. So the Electrologic relay controls, this is an area where this is all keyed off these high-speed inputs. You can set what values that you want, as we saw in the power quality limits. And you want to trigger whether you want to force an output on a particular piece of equipment. This is where you can use this logic relay control. So this is, it could be something that could be beneficial for tracking under voltage alerts, or if you want to shut down equipment if they exceed a certain threshold, something like that. So this meter again has, I said power quality, it's waveform capture. I may have to correct myself. This waveform capture is available in the 1272. 1262, I don't think it has this feature. And then maybe with my people that are online, they could correct me on this, but I think it's the waveform capture is available in the 1272 and not in the 1262. So here we have waveform capture enable for all the points that we chose, and PQ is checked. And here we have the different sampling rates that we can choose. This meter has up to 512. One of the things from experience, I found that you really, it all depends on what's important to you. Normally most people would want the highest sampling rate, but with the 1252, it comes at a cost, and you're going to end up losing data if you do not, or can't lose events if you don't, if that sample rate is too high. So a comfortable rate is 128 samples per cycle from my experience with the 1272. But again, it all depends on what's important to you, and but it does have a high sampling rate of 512. So if you want to sample for a short time, 512 might work really well for you for over a period of time. If you really don't want to lose any event, the rate is not as good as 512, but you can capture the pre and post trigger information. And here they are assigned to, you have choices assigned to KYZ input. So it's basically all the power quality events are going to a KYZ counter. as opposed to, and if I could go back a little bit, let me see, where is it, KYZ? I'll have to get back to that later. Anyhow, so this is all triggering all 8 inputs to KYZ input. So we have, yeah, this is where it is. So here is where we have our 8 inputs, and you have the option to choose waveform trigger, and so, or make those changes. So I would think that this would have been placed further up in the order of programming, but it follows afterwards. So so if I wanted a waveform PQ trigger on an input input 1, I would be able to select it from there. And if I go down to do KYZ, I could set the first 2, and let's say if I go there and I go back to my PQ recording, you can see that the information is inputted or inserted into that. So that's where the changes are taking place. And so operational status input is generally gives you, it's basically a status input of if the meter is alive, or if it's up and running, if it's working properly, if it's pulsing. And this is what this this output is. Some folks may want notification that the meter is active or it's not dead to generate operational status pulses. So that's what that is. And it comes out on an internal pulse relay. Trending. So we go down to trending and trending log intervals on the 1272 meter. You have, we talked about the 5-minute data, which is, you really want to sync this with the information that we talked about earlier with the interval pulse and accumulation level. So that interval, so that has to be in sync with that. Otherwise, there's an issue with your data coming in the trending logs. So there's a set for 5 minutes. There are 2 logs. And if I get 2 logs that you have available, and we'll go down to the next, looking at the trending logs. So the trending logs on these are, and all the meters have trending logs that are, minimum you'll see is 2, and goes up to 8, maybe 8 or 9, depending on the type of meter. The Nexus meter was the first meter that really had multiple logs. So it had more than 1 log. And so in this log here, there's a lot of information that you can trend basically. And so measured values, you have average values, you have accumulators, interval accumulators, and external IO and cumulative demand values. Here you have thermal average, maximum thermal, and so on. So this is just a multitude of information that you could program. All the quadrants you could set, and these are energy values, accumulators, measured or watts, bars, and volts, and so on. So you have all those inputs that could be going to a high-speed input. You can have this set up for secondary, primary, secondary values. So the meter has KYZ. You can have pulses internally, pulsing internally and as well as out externally, and that would be your, and you would trend that in your logs. So let's close this, and that's basically the log information. External modules, these meters support many different type modules. These are all our different modules, external modules. We have the 4PO1 KYZ output, the 8 digital output. So we were talking about digital inputs before. You may want to add this module to provide this external signal or contact to whatever piece of equipment that you may want to send messages to, or alarms, trigger some kind of function or physical switching or whatever it might be. These are the analog modules, 4 to 20 modules. These are the 4 port, and these are 8 port modules. These are the 0 to 1 milliamp modules, analog modules, and then so on. It's pretty self-explanatory. And this is where you would add your modules on the 1250, 1272, 1252, 1262, 1272 meters, 1450 meters. So you would just, it's pretty much the same area, same designations, similar modules. I'm not 100% sure if there might be changes, but I think they're pretty much the same type. And here they're addressable. Each one of these modules have a different address. And these go, again, they would be connected on your 485 port, ideally. If you piggyback some of these different modules, anything we recommend, any modules, more than one is recommended to add a PSIO, a separate power supply, that we also sell, that would provide the power requirement for the for those modules. And this is, again, this is where you would set these up. As you add them to the system, you would hit update, and you would program the meter. So it pretty much, so that's a 1272. So that, as you can see, it's a lot of things in there, and it could be confusing. We always recommend, if anyone's having trouble, you purchase a meter and have installation issues or trying to get these to work, give us a call and the tech support group, and we'll help you get it going. Okay, let's see if we could close. At the end of this, generally we recommend that you save the program, and see if I can move this down. Save the program and then update the device. And I generally like to run a report and so on. You have the option also, if you save it, you can load it into another meter. If you have a similar meter, let's say this meter, you wanted to update to another 1272, you would load this configuration in that meter. And that's typically the approach. So update device writes all the information to the meter, all the changes. You will get this message. I'm going to, following items like here, we modified the waveform PQ log. It's going to prompt you to retrieve the logs first before it actually does the update. We're not going to proceed with the update anyway, because this meter is in our lab and I don't want to upset anyone that it could be using this. So I'll exit from the 1272. That's just the 1272. And again, the 1262, 1272 identical, except for the waveform in the power quality section. But they're identical. The 1252 meter, I don't have one with me, or I couldn't find one in our lab. But the 1252, we moved away from the 1252, or the upgrade from the 1252 is a 1450. And the 1450 is just a powerful meter that we sort of went through that a few minutes ago. It has it does a lot. So let's just drop this connection here and let's take a look at the 1450. So can you see my screen? Hopefully you guys are still with me. You can see the screen. Okay, I'm going to launch the connection to 1450. So I have a meter here in my home office that I'm working with. I have several meters that are connected. So that's what I have. Those are connected at a 10 dot address. The meter, the 1272, previously just looked at, was in our factory that did not want to make changes to. So here is a 1272, I'm sorry, 1450 meter. And I'll just disconnect. So I'll connect. So I'll go to the connection manager. So in this, and I always use this feature in a 14 in any of the meters that we use. So it just basically stores all the meters that I'm polling, and I don't have to keep remembering what the IP address is in order to connect. So it's basically a phone book. And so what I did was I created different phone books with different meters, different locations, and so on. So the training Nexus 1450 if I edited that, that's what the IP address I have, which is my local connected to my network. And these are the settings that I have in that. So it's a Modbus TCP. This is more descriptional than anything else. It really doesn't, affect, it should be 1450, but it'll still connect either way. At least from my experience, it does. So I'll go in and connect to the 1450, launching the training 1450 meter. Okay, so when you first connect, this is a status screen and firmware information. Tells you what V-switch, which is the different options that this meter is capable of when you purchase the meter. You have the COM state, everything looks good, and password is disabled. Again, the 1450, and you could go to the website, you'll see all the information, what it does. The brochure explains. I really just wanted to do more of the programming information, which is once you purchase it, what can I do with this meter? And it just gives you a lot in this version, this meter, this model. So I'll click OK. Just a quick look, polling, I'm polling, this is a small load that I have, and that's the polling screen. This is a Phasor diagram, so everything wired single phase, so it's all ABC currents, all voltages are in the same phase. So you get all the Phasor diagrams, which is pretty nice, which is good to check wiring, and just to check, just to make sure that everything is working properly. And so those are very important pieces. This meter is generating a heck of a lot of harmonics. We started looking at it yesterday with my colleague Trent, who's on with us, and this is behind a UPS that I have. This is installed on a UPS, I should say. Behind the UPS, it should be very clean, but as you can see, there's a lot of harmonics generated here. So from this, if you looked at the spectrum, this is what the fundamental, and here are all the harmonics. So this is a 1450, it's very sensitive meter to picking up all these harmonics on my system. So I just want to go over that real quick. The log status of the meter, when you click on this meter, it has all the historical logs. So in this meter, it has 8 historical logs. I've got 58 records. It's got tons of memory. Again, it basically it's polling, and this is updated information as of this morning at noon. So I'm just over an hour in the presentation, and basically these are the records that I can retrieve. So what I'll do is I'll go to the programming first, and then we'll look at retrieving logs from this meter. So let's take a look at the profile. You're familiar with the profile icon that retrieves the data, retrieves the programming information, and that's where we do all our program settings. Okay, so here we have 1450, and same information we saw with the 1272 general settings. This meter is, I have a 400 to 5 CT, and that's 120 volts primary and secondary. So it's a 1-to-1 ratio here. This is 80, was it 584? Yeah, 80 to 1. And here we're doing Y configuration. Just as we said before, similar hookup, Y delta, 2 delta, it's 2 CTs. It's not as verbose as the other drop down we saw for the 1272, 2.5 element 4-wire delta. So you have all the choices depending on your configuration, an arithmetic sum or vector sum calculation, whichever for producing VA type reports. So we click close that. So here's our calculation, just like we saw in the other case, based on what we chose, 400 to 5. In this case, as I mentioned before, I think I took a quick peek at my load. It was like 1.19 amps And I'll just take a quick look again. We'll just exit here for a second to confirm. So just to see, 1.16 amps is really what I want to set my limits eventually. So I want to really key that off of, so I'll go back in, CT, we said we'd do that. Let's see if I wanted to, oh, sorry, limits. So we wanted to change that to 1.16 amps. It's 100. So when it does its calculation, so this is 120. So that should be 120. Oh, I'm sorry, 208, three phase. There's obviously no three phase here. But basically you make your changes here. I'm not going to update anything, but this is where you would enter in all your values, and you have to do your calculations. So V times I, and that would be your watt total here. So this 48K would be, let's say, 120 something, right? So basically, again, I'm not making any changes here. And power total would be your total watts, the 3 times each power phase, right? So let's go down, and then time settings. So we're looking at disabling user, same thing we saw with the 1272, and synchronization here. You have a little bit more. You have IRIC B, you have line sync, 50, 60 hertz, SNTP, and so on. IRIC B, just if you have the equipment, is the best time sync. If it's my experience, if you lost power, you lost satellites, because it's basically pulling the time from the satellites. If you lose it, that you have to make sure you get a time sync server that has a failover system, that if you lose its power, it doesn't fail to transmit the updates for the time. So that's important to know. So anyway, so this is a time sync for IRIC B. If we set that there, here we went with the labelings. Again, it's similar to what we saw in the 1272. Nothing's changed here. Communications on this meter. So you have a big difference here on the 485, on the 1450. You have 4 ports we talked about, and then there's 2 Ethernet, one's a fiber port. So these are electrically isolated ports, so you can have two network connections. And here is where you put your modules or your display outputs. You can set your addressing and so on. So again, here we shows, and for port 2, we're getting DNP 3.0, so that your SCADA folks are getting 0.2. Here could be something else. Either you are hooked up to a display, or you could be reading that over Modbus RTU and so on. And these are typically where you see 57.6 designated for modules, external modules. Like we talked about the analog, the KYZ modules and so on. You use those. And so here are your network connections, advanced settings, and we go into the advanced as soon as that opens up. And here you have all your different options, port 5 and 6. Important to have one of these available if you want to be able to talk over Modbus TCP over IPv4. Okay, so to play it safe, you could just enable both and you're good. If you want to disable one or the other, you could do that. 502 is the default Modbus TCP port number. All our meters default to Modbus 502. GE, we saw that in the other, it was laid out differently. Here you have enable, disable, auto, and so on. Strongly recommend disabling that. Here we have time sync, which you can have different ports doing your time sync, SNTP, simple network transfer protocol. So that's it for time sync. Your DNP, just like we saw before, disable listening port. You can enable it by clicking on standard, which is, if I said manual, Yeah, but it's enabled. 20,000, you have DNP addresses that you can configure it for. And again, similar to what we saw previously. So we could close that out. When you enter this information, you want to update your note when you're setting this up. You need your subnet. You need IP address, subnet mask, and default gateway. You cannot, unless you're working directly on that machine, you have to know what the default gateway is. And sometimes it's totally different subnet, and so that has to be entered in here in the default gateway. So we go down to configure high speed. High speed updated rate can be, I'm not sure what this is, and if there's a question on this, you could please ask, and maybe we could get an answer for it at the end. So let's go down to power quality, and here are our limits. And so here we have the limits established, and everything looks very similar what we had as far as the limit thresholds. And Electrologic relay outputs, just like we discussed before. This also provide all your high-speed inputs that you want this logic diagram to produce. And so that takes care of that. This meter also takes your digital inputs, just like we saw on the other. And here goes a waveform trigger. We have all the options: event triggered, block, window, waveform, or KYZ. All right, so and then now we go down to trending. And so trending logs, these are our 8 logs that we talked about, and trending intervals, and these are 15 minutes in this particular meter. So energy scale is log 1, and you have there's a 15-minute data. You have 341 days. You can run. There's a lot of memory in this. You could store in for this log, and it all depends on how much information you're recording for this meter. So if you wanted certain other quantities that you wanted to program, you can always add, and we still didn't impact our days, our number of days on this, but basically days available. So this could be one log, and you just update the information to see if that works. The check HHF function is it really applies to people who are MV90 users. Itron is a manufacturer of electric energy meters, gas meter, water meters, and also software that connects to these meters. The software they produce on MV90 can talk to many meters, over 200 meter electric meter types that I know of. So most meter manufacturers try to comply with MV90 functionality, or being able to use an MV90 system. So this allows you to generate an HHF file, a handheld format, I think it's called, to produce a file format that can be imported in MV90. And this is in the event that you're not able to talk with a meter over a network or remotely. You go to the site and you want to dump the meter, you would produce an HHF file and then import it into your MV90 system. So that's what that is. So this checks whether this will work. It says invalid log settings. So it says, I don't like what you put in there. So if I took out these other functions that I added in for MV90 and I check HHF, it says now they're valid. So that's something that is you want to check if you use an MV90 system. If you don't care. This only applies to MV90. So if we go down to same thing, external IO modules, it looks just like what we saw before. Again, this is the 1450. We're really pushing a lot of the 1450s over the 1252s. It's a much more powerful meter, and 1252 is really approaching the end of its lifespan, if it didn't already. So anyway, so this is basically it for the 1450, and I'm just going to jump to the disconnect and go to the 1500. So here we look at the it's like different models of cars. If you want, without a good description, if you could say, I want a higher, these are high-end meters, by the way. These are not, they're high accuracy, high performance revenue type that people who are responsible for very sensitive data, energy data that they want to record. They want to look at these type of meters for that application. So the 1450 is 1500 is, let's see, 1500. So this is a 1500 plus. Let me just make sure I didn't. Yeah, so this is a 1500 plus. Was this the one that? Okay, I just want to make sure I got it right. Okay, 1500 plus. So let's back up a little bit. 1500 plus. Here we're polling. This is same load roughly. This is what the waveform looks like. It's on the same side. Here I'm seeing all these harmonics. And this goes up to the 100 and let's see, 127 harmonic. And let's say these are what it looks like from the spectrum. So this is very noisy. I suspect it's my UPS is putting out, creating all these harmonics. And this is what is a typical environment with what UPSs are doing. And you really want to monitor harmonics. And if you know, utilities, it could create a big problem. It's basically heating effect on the wires and inefficiencies in the system electrically. So you really want to remove these. Internally, what people would do, let's say if you put a UPS, it produces a clean output. So downstream, your load looks, or the equipment that you have the UPS connected to is getting the right voltage or sine waves that you're looking for. But on the outside, that's going out to your next door neighbor, your customer, whoever is on the your utility, they're now seeing all the noise that these are producing. So the goal again is to use power quality equipment like the 1500 plus 1450 that can capture a lot of these type of events. So I'm just going to go profile again with the 1500 plus. We take a look at the CTPT ratio, same thing, same choices, right? Here, 4-wire delta is 400 to 5 and 14,400 to 120. So I have a different ratio here than the other one. The limits here are actually, these are values that I put in there that I was talking about. It's 400 to 5, but you put in, I put in the values and did the calculation. So this is what I am expecting to see for my limits. And if I scroll down to time settings and time zones, same thing. You have the same choices, pretty much. IRIC B, line sync, SNTP as the 1450. Your labeling and same information that you would see as the 1252, 1262, 1272, 1450, 1500 plus. Pretty much laid out the same way. Communications on this is a 1500 plus. It has optical port. The 1450 does not have an optical port. The 1500 has all these serial has a USB serial, 485, 480 it says, and you can configure these depending on what equipment that you're connecting to them. And again, we talked about, for 57.6, typically the modules default to 57.6. They end up on these ports. So this has one Ethernet connection here, and this the 1500, one MAC address, I should say one address there. And here you have, again, you have multiple options, web server, they all have a web server function. You can set your port 80 for, and you could change whatever. If that's being blocked by your IT folks, you may choose another port number. And as you saw previously, very similar choices. Here you have SNTP's time sync card. You have a couple of them that you could put in there. 61850 protocol supported. And again, that's a big part of this meter is 61850 certified. That's a better word. So you have DNP. If I could go, if I could click, is it responding? Okay, DNP is not turned on from here. So, but you have options for DNP, just like you had. There's a DNP mapping table, which we have online, which you could download. Again, you do alarms and emails. You get all this in all these packages, right? So the DNP plus, as we talked about here, the DNP, I should say, uh, settings, and we, again, similar setup as we saw previously with the 1272. And here you have the ability to configure the size of your log sizes. So here you have basically 10 blocks, memory, 10 megabytes, and this is how much memory you have left, roughly 3,000 3 gigabytes or 3,000 megabytes available that you have available. Tons of memory in this. Let's jump down to revenue and energy. Similar configuration that we saw, the global settings, all the changes, internal KYZ. This meter has 2 pulsing LEDs and 2 KYZ pulses. So the meter has either the pulsing, you could put an optical pickup to pick those up, or 2 KYZ, as opposed to the others had the 4 KYZ or the 1272 had 4 KYZ, and it had 1 LED output, 1 pulsing LED, and again, we use that primarily for testing. Okay, and that everything else pretty much is the same. CTPT compensation, transformer line compensations, all done similarly. The interval size that we talked about, pulse 15, and time of use, again, enabled. That's a totally different section when going over time of use. Again, we're talking about programming. If you enable time of use, you can make use of the time of use function. Power quality and limits, and all of the limits that we talked about here. We have the power quality information, I should say. With this meter, you have voltage trigger, current trigger, and you have transients. So it is picking up transients. And at the conclusion of this part, we'll go back into the, to retrieval logs, and we'll take a look at waveform capture, and that should finish up on the subject of programming. So basically all our functionality here, based on we're using 212% of the 120 volts. So that's what we're looking at, voltage transients, and this is the IEC 61430 volt interruption set points. So, and these are the current triggers. These are all PQ enable, PQ and waveform enable. And so we should be capturing all these events, doing showing the harmonics. It's going to trigger a lot of alarms, and we're going to get to that in a second. That's going to help us get an idea of how badly our hookup is, or where we're getting our feed from. So here we have a bunch of different things here. I don't know if we covered this other piece, the I2T function. Those are primarily used for sizing fuses on overcurrent type. So it's basically the energy that energy value that I2T is an energy value that basically it's the and how can I say, the energy that the fuse, a line fuse might experience during a surge or some overcurrent type condition, and you want to size that. The I2T is useful in gathering that information in determining what size fuses to use. So that's what we use I2T and V2T for. The high-speed inputs, we talked about that before. So here, whichever event triggered log or waveform triggered log, KYZ, and those are some of the things that we're going to see what waveform are we triggering on. And then as we go down, operational status, we talked about that. It's basically showing the heartbeat of the meter. Is it dead or alive? Um, uh, the short-term max, minimum, average intervals. On this, I'm not very clear on, and maybe again, if you have a question on this, please ask at the end of the session. Cancel that. I'll go on the trending log time intervals. And so let's go to trending setup. And so this is again what we chose from our drop down. Energy scale, interval energy scale, these are different. So energy scale came from the accumulators. These are accumulator values. So if I want that, you see just come in there as energy scale. If I want accumulator, interval accumulator. So energy scales are actually meter readings that are being recorded. And if it's 15-minute blocks, it's stored in the meter every 15 minutes. It's actually a way of looking at what your meter reads would be every 15 minutes. If it's stored at 15 minutes, 5 minutes, 30 minutes, or an hour. So let's say if you were polling the meter and you set it for energy scale, you want to retrieve the logs and you want to find out what was the reading at midnight on this date. That's a good location, a good choice to program energy scale values. Interval energy or interval accumulators are the actual bundle of energy that's stored within those intervals. So it's a start and stop reading, netting the two for that start of that interval, end of interval, the total energy for that interval. So that would be interval energy. So if I wanted interval energy, that would come up as such. Then you have other functions, other things that you can bring in, but those are the primary energy values. You have a bunch of things you could bring in, uncompensated numbers. If you have a meter that is being compensated and you want the uncompensated value, and then if you want to profile as well as you want to bring in compensated. So if you program the meter for compensation, automatically by default, it will display only compensated values. If you want, again, you want to look at the uncompensated value, you want to program the meter. And if you want to see if the meter is compensating correctly, the losses should be a certain value, you'll be able to look at this in the trending log. Yeah, this is one way of viewing it. Okay, so the next is the external modules. And here we have the similar setup. You want to add the modules, same type, same module. So these are all kind of, I would say, compatible as far as the modules are. So you could use the 1272 uses the same modules as the 1500 plus, as the 1450, as the 1252. So if you have a set of these modules and you're replacing the meter for an upgrade, you don't have to replace the modules. Typically, the program is stored with them. You just have to add them to the device. So that should not be an issue. Then you have optional cards if you want to add in there. So let's exit that. Let's do a retrieval log. And so we're going to retrieve the logs for the 1500. So I read it this morning sometime, I think, and I'll try and get the power quality. And hopefully it goes by fairly quick. So this is the Retrieval Manager. So it gives you a nice picture of the progress as it's retrieving the data. It's querying interval log 2. So all the check boxes that I have, it's going to grab information for all of those. And there's a status as it's bringing in the data. It's going to highlight each line. These are all the events, and if we talked about all the events, I just scroll up, it's showing up transients that are showing up basically on the so if I wanted to look at this, show waveforms or show PQ, so that would be the waveform. These are basically all the parameters that we set for the limits. These are pass, fail, or basically pass, fail, or low set points. trying to go back. Trent, can I ask for your help for a second?
Sure. Yep.
Can I view the waveform from here? Is it I need to go back to choose waveform capture?
You'll want to go back to the waveform. If you scroll to the top, yeah, that's fine. Yeah, if you
so
hit
go to
waveform,
waveform, yeah, because I had power
Yep.
quality.
Yep.
So this should be a lot quicker, hopefully. So here is, these are showing me positive transients that are taking place, VC to N. Not sure why it's VC to N, because they're all parallel voltages, but so I double click on it and I want to see the waveform. And let's see how long that takes. So as Trent said, you can export to different formats, ComTrade. Typically, if someone requests this information, you would just go through this process, and then they have the software to view it. So, so this is what the waveform looks like, and this does not look like a normal waveform. So this is telling us there's some transients occurring on VCN, which is this one here. And if I could take my screen. Okay, so is it I think waveform? If I want to take a look at that screen that we looked at, I can't.
Double click on VCN on that.
Okay, double
waveform for
oh,
VCN.
Yes.
Yeah.
And then
you can turn the details on.
Details, yeah. So this is a representation of what the waveform is. VCN and basically the information, the harmonic content as you flow through, scroll across all the different harmonic levels that it's captured during that this download. So these are considered transients. Okay. So that's basically the information that could be very useful. But this is just one piece of the waveform capture that you can use. But there are many other features or areas in the program that you can use to evaluate the conditions of your quality of your electric service or the quality of your equipment. So, but that's basically what we wanted to show you today, and we saved the best for last. And unfortunately, it's not as long as we could have gotten the time in, but basically producing all the, getting all the information in the meter, programming the meter, generating this information in the end, retrieve the log information so we can look at the data as we did previously. If I hit the back button, it takes me back, and I could close that and back. And then if I just want to look at what the load is, these are the energy start and stop readings we talked about. So scaled energy every interval. There's a 5-minute intervals. It's recording our meter reading. So if I looked on the display of the meter, if I looked here, it's 590.78 something. So so this is the increment from the last. So as you can see, it's incrementing. So those are actual meter start and stop readings. This is the scale energy and interval. That's the energy that we talked about, the calculated energy. So if we netted the two, that's 9.9. Did I get that? 79. That should be the difference. And wait a second. That doesn't look right. Sorry. But it's recording KYZ pulses per interval. And then you have to know the multiplier, which I don't know off the top of my head, but these are values that's coming in. So that's the difference between the two intervals. So that's what it is. And so getting back, these are some of the things, I guess, what we talked about. We could view the power quality, you look at system events, and this is a lot of events here. So every time you access the meter, you make changes. These are all the events that are recorded. Typically, the system doesn't allow you to delete this, and you probably would not want the ability to delete events, okay, for auditing purposes or any other. These are the options that Trent talked about: keep PQDIF format or ComTrade, and that's basically it. I think we covered pretty much um, most of what I would like to cover. I think we're running out of time, but yeah, so that's basically it. And with that, I'd like to thank you all for participating, attending, uh, for your contribution. It really was good to really have an audience that hopefully you could get something in your hands that, or you could walk away and say you could use this from here on. So appreciate it. So my name is Norman Clark. The product is Electro Industries Gauge Tech. Again, our website is electroind.com. All our products are online, all the information on our products, all the technical documentation, all the requirements that, or all the information that you need generally to do an evaluation if you're pursuing a survey of a kind. I always tell folks, you really need to do an energy survey or survey your equipment in your building and just get an idea of what your loads are. As I said, there could be inefficiencies and performance issues that you could address. And especially today with the emphasis on energy conservation, it's very important to be able to conduct these type of surveys to get an idea. And these meters are a great tool to get you there.